Hello friends, welcome to mathematics video lecture series. Today I want to talk about locus of a straight line in complex plane. Let's begin. Locus of straight line in complex plane. Okay, it's very simple. We'll use the exponential form and it's extremely easy. Okay, and it's extremely intuitive. So suppose there is a complex number z1 which is at an angle of theta. Okay, I want to write this complex number. How will I write it? This complex number can be written as mod z1 e to the power I theta. Okay, now just think about it. Suppose there is a straight line, at an angle of theta with positive direction of x-axis and passing through the origin. So there's a straight line which is making an angle of theta with the positive direction of x-axis and it is passing through the origins. So the line will look like this. This is the origin and it is making an angle of theta. So any general point z on the line, if I'm able to write the equation of z, then that, since z is a general point, so that will also be the locus of the line, because as you will change z, the point will satisfy the equation. Okay, so how to write any general point? Use the above information that I told you in the beginning. Any complex number z can be written as mod z e to the power I theta. Okay, so any complex number can be written as mod z e to the power I theta, and this z is a general point, so this is a variable, so any point will satisfy this equation. Okay, any point on this line will satisfy this equation. Suppose the point is here, then it will satisfy this equation. If you put that point, let us say z1, in this equation you'll get z1 is equal to mod z1 e to the power I theta, so it is satisfying. Okay, so this is the locus. So locus of a straight line which is making an angle of theta with the horizontal and passing through the origin is nothing but z is equal to mod z e to the power I theta. Okay, what about a line if it is not passing through the origin? Suppose this is a line, then what? Yes, we have the solution. Let's see. So straight line at angle theta with positive x-axis and passing through any general point, let us say z1. Okay, so this is the line with the positive direction, it is making an angle of theta, and let us say it is passing through a general point z1. Let me draw any general point z on the line. Let me call this fixed point as a and this variable point as b. Can you write AB? Can you write AB? Yeah. Coordinate of B minus coordinate of A. Basically, you are going from A to B. So head minus tail, coordinate of B minus coordinate of A. So coordinate of B is nothing but Z. Coordinate of A is nothing but Z1. So AB is nothing but Z minus Z1. And I've already told you that any complex number can be translated. So I can translate this complex number in parallel to itself, and I can make it to pass to the origin. Okay, so this is essentially z minus z1, and it is making an angle of theta with the horizontal. Okay, so AB will be nothing. AB will be nothing if the length is, let us say, r, then I can write z minus z1 will be nothing but r e to the power I theta. Okay, so this r represents length of AB. This r represents nothing but length of AB. So I can write it as z minus z1 is equal to mod of z minus z1 e to the power I theta. So we have used two concepts. One is obviously the concept of head minus tail, and the other is the concept of how to find the magnitude. Combining this, we get z is equal to z1 plus z minus z1 mod e to the power I theta. This is the equation. So this is the locus of straight line that is passing through z1, and it is making an angle of theta with the positive direction of x-axis. Okay, so I covered the locus of circle in the previous lecture, and now this is the uh, locus of a straight line. Okay, stay tuned, we still have a lot of things to cover. Okay, so we'll meet in the next video lecture with some new topic. Thanks for watching and have a nice day.